Hello again. All right, to be notes. So this is just an extension of solving rational equations. Day 2, like it says. So how do we use these rational equations to solve real world problems, aka word problems? Okay, hopefully you saw that little clip that I posted on Schoology from that movie Little Big League, or I think, yeah, Little Big League. Kind of an older movie, so if you've never seen it before, I understand, but it's pretty cute. And I just thought it was so funny that if you pose this question in real life, that's probably how people would react. And notice what example 1 is. It's that same exact problem that little kid in the baseball locker was trying to get help with from all those people on the baseball team. So in these word problems, rational equations use a lot of rate type problems. So if you think about work is equal to your rate times the time it takes you to do that work. Okay, and we can rewrite that as rate equals work divided by time. If I divide by time on both sides, I get work over time equals our rate. All right, so that's exactly what we're going to be using in these word problems because it's real life word problems. So it says Joe can paint a house in 3 hours and Sam can paint a house in 5 hours. How long will it take them to paint the house together? Well, the first thing I'm going to do is write out those rates. One for Joe, one for Sam. So I'll just make a little note here that Joe, his work is painting a house. Is one house. How long does it take him to do that? What's his time? 3 hours. Okay, that's his rate. One house for every 3 hours is what he can do. Sam, on the other hand, he can paint one house, but it takes him 5 hours. Okay, we are wanting to know how long is it going to take them to do it together? Together means we're going to be adding these two things together and trying to figure that out. How long is it going to take them together to paint that one house? X hours. Okay, that's them together. Notice I'm adding these two things together. So let me make this a little bit smaller, give myself some more room. Okay, think about your fractions here. 1 over 3 plus 1 over 5 equals 1 over x. You have to get a common denominator. 1 over 3 plus 1 over 5 equals 1 over x. Your common denominator is going to be 15. So if I rewrite that, I'm going to get 5 over 15 plus 3 over 15 equals 1 over x. You can combine those two left fractions together and get your 8 over 15 equals 1 over x. And now I can just use that cross multiplication method. Boom, boom. That gives me 8x equaling 15. Dividing by 8, I get 15 over 8. So a little bit less than 2. It's not very realistic for us to say, oh, it's going to take them 15 over 8 hours. So here it would be appropriate to rewrite that as a mixed fraction. So that is 1 and 7/8 hours. So like I said, a little bit under 2 hours. And if you want to convert that to 1 hour and however many minutes, go for it. Okay, that's it. That's what we're going to be working with. Okay, so jumping into example 2. It says it takes Harry 7 more hours to paint a kitchen than it does Sally to complete the same job. So we don't know how long it takes Sally to complete the job, but we know that it takes Harry 7 more hours to do that. So I'm going to go ahead and write those two things out right now. When Harry met Sally. That's a movie. All right, Sally, we don't know how long it takes her. That one kitchen in however many hours, we don't know. Harry, on the other hand, we know that one kitchen takes him however long it takes Sally plus 7 hours. Then it tells us together they can complete the same job in 12 hours. So that means adding these two things together give us that one kitchen in 12 hours. And there we go. We have a a fraction plus a fraction equals another fraction. 1 over x plus 7 plus 1 over x equals 1 over 12. I'm going to get that LCD on the left-hand side and cross multiply. That LCD on the left-hand side is not x plus 7. You cannot just add 7 to that second fraction, okay? You have to have a LCD, and this time it's going to be x times x plus 7. So rewriting these fractions, I'm going to get that first fraction would have to be multiplied by x, so that would give me x over x times x plus 7, plus the second fraction would have to be multiplied by x plus 7, so that would give me x plus 7 over x times x plus 7, still equal to 1 over 12. Now I can combine those terms on the left-hand side. That's going to give me 2x plus 7 over x times x plus 7 equals 1 over 12. I can cross multiply here. Boom, boom. 12 times 2x plus 7 is going to give me 24x plus 84 equaling 1 times that x times x plus 7. I'm going to go ahead and distribute that x and get x squared plus 7x. And so now I can put everything on one side and solve. And so I have 0 equals x squared minus 17x minus 84. So I need factors of negative 84 that add up to negative 17, and that's going to be negative 21 and positive 4. So when I factor that out, x minus 21 and x plus 4, and I solve for x, that means x is equal to 21 and x is equal to negative 4. Well, if x is representing the amount of hours it takes Sally to paint that kitchen or whatever, paint the kitchen, then can x equal a negative number? No, x cannot be negative 4. X has to be 21, okay? And that makes sense. If it takes her 21 hours, it would take him 28 hours. Together, it would take them 12 hours, about half their time working together. So that makes sense. And that's really good to think about when you're answering these questions is, does my answer make sense? Realistically, does it make sense? Okay, be careful here. I almost made a huge mistake. Notice the question asks, how long does it take Harry to complete the job if he works alone? Well, x is 21. That's how long it took Sally to complete the job. Harry is x plus 7, so it takes Harry 28 hours. And I said it, I just boxed in the wrong thing. Okay? Alrighty, moving on. A car travels 500 miles in the same time that a train travels 300 miles. The speed of the car is 30 miles per hour faster than the speed of the train. Find the speed of the car and the train. So this is going to use a little bit of a different equation. We're not talking about work and rate and time. We're talking about distance now. It's traveling the same in the same time but different distances. Distance is equal to rate times time. Okay, so another way of writing that could be distance over rate equals time. Okay, so in terms of the car, we know that it's traveling 500 miles. That's the distance it's traveling, 500 over its rate. We don't know that just yet. But the train, in the same time the train travels 300 miles, so its distance is 300 miles over some rate. Notice it says in the same time they travel that. And it says the speed of the car is 300 miles per hour, faster than the speed of the train. Miles per hour, that is our rate. The speed of the car is 30 more than the speed of the train. We don't know what the speed of the train is. X. The car is 30 miles per hour more than that. It's faster than that. Whatever X is plus 30. What do we know about their time? 500 over X plus 30, that's distance over rate, that equals a time. 300 over x, distance over rate, that's equal to a time. Same time. Set them equal to each other. Cross multiply. Okay, cross multiplying, we're going to get 500x equaling, I'm going to go ahead and distribute. That would be 300x plus 9,000. I know you're thinking to yourself, oh my God, Miss Tricks, these are huge numbers. Oh my God, oh my God. Calm down. Okay, we just got to solve for x now. Subtract, you get 200x equal 9,000. When you divide by that 200, those zeros are going to cancel out. X is equal to 45. So what is x representing? That's representing the speed of the train. But notice our question says find the speed of the car and the train. So that means the car is going to be 30 miles per hour more than the train. Well, the train is 45 miles per hour and the car is 30 more than that. Then the car is going 75 miles per hour. Is that realistic? Absolutely. Okay. You want to make sure that you're answering the question. You want to make sure that your answer is realistic. All right, so those are your word problems. Remember those kind of formulas, distance equals rate times time, or distance over rate equals time. The work is rate times time, or work over time equals rate. Those are the two main ones that we use for these rational equations. The last four problems are called literal equations. Okay, literal equations, meaning there are no numbers. And if there are, it's not something that you're going to be simplifying the numbers. You're going to be using more of variables. Okay, so in our first problem, it says we need to solve for x. So we have b over x minus c over y equals a. Well, what would you do first? I would find that common denominator on the left-hand side. Okay, notice our common denominator has to be x times y. So if I rewrite this, I know that I would have a by over that xy. They have the same denominator, so might as well put them together. And then my second fraction would have to be multiplied by x over x, and so that would be minus a cx. That's still equal to a. Okay, our goal is to solve for x. So what I'm going to do is I'm going to get rid of that fraction on that left-hand side. Make this a little bit smaller so I have some more room. Okay, so get rid of that fraction by multiplying by xy. So now I have by minus cx equals a times xy. Okay, and I could really drop those parentheses because it's all being multiplied together, axy. Okay, I'm trying to solve for x. So I want all my x's on one side, all my non-x terms on the other side, I guess you could say. So I know that cx has an x in it, so I'm going to go ahead and add that over. So now I have by equals axy plus cx. If my goal is to get x by itself, take that out. Take that GCF out. So I'm going to come up here. So taking out that, I'll get by equals x times ay plus c. And so now I can just divide both sides by that ay plus c, and I get x to be by over ay plus c. There you go, final answer. Sorry, my work is kind of messy. All right, part B. Might help if I do that. P plus x over 2 plus 3 equals x. I want to solve for p. Well, the easiest thing I can do first is subtract that 3 over. Move that 3. You don't have to multiply it or divide it because it's being added to that fraction. Subtract it. So now we have p plus x over 2 equals x minus 3. Now I want to get to that p. That fraction's in my way. Multiply by 2 to both sides. P plus x equals 2 times x minus 3. I want to get p by itself. Subtract the x. Hopefully you know that this is 2x minus 6. And so if I just subtract x from both sides, I'm just going to be left with 1x minus 6. Done. Final answer. All right. Going down here. All right. We got to solve for x again. This time I have a fraction equaling a fraction. Method 1. Cross multiply. Boom, boom. u times a minus x equals a minus u times x plus u. All right, I'm going to go ahead and distribute and multiply everything out because I want to get all those like terms together and then try to solve for that x. So distributing, I get au minus xu equals, if I FOIL this out, you might want to pause here and FOIL it out, you would get xa minus ux plus ua minus u squared. So then I could combine all my like terms, and that is going to give me u squared equals xa. And so if my goal is to solve for x, all I need to do is divide by a. So u squared over a equals x. Done. Final answer. All right. And then part D, last part. It says v equals 1 over s plus 1 over t divided by 1 over s minus 1 over t. And you might look at this and say, oh my God, this is a lot. No, it's not. Take it piece by piece. You can do this, okay? Our goal is to solve for s. So what I'm going to do is I know that I need to get that common denominator in the top and the common denominator in the bottom in order to simplify those fractions. And I'm hoping that you can see that our common denominator in both the numerator and the denominator is going to be st, right? So that means v is going to be t plus s over st divided by t minus s over st. Well, you know that dividing by a fraction, you can just multiply by the reciprocal. You can rewrite that. So now I have t plus s over st times st over t minus s. Well, what do you notice about those st's? They are going to cancel out, right? So I just have v equals t plus s over t minus s. We're not done yet, okay? We need to solve for s. That's our goal for this whole problem, is to solve for s. But now at this point, it makes it feel a little bit easier. Kind of feels like something that we've done before. Get rid of that fraction. Multiply both sides by the t minus s. So we have v times t minus s equals t plus s. I can go ahead and distribute that v. So vt minus vs equals t plus s. If our goal is to get the s by itself, we need to put all the s's on one side and everything else on the other. So I can add that vs to both sides, and I can subtract that t from both sides. So now that's going to give me vt minus t equaling vs plus s. Okay, and so if my goal is to get s by itself, I can take out that GCF of s. I could also take out the GCF of t here if you'd like. It doesn't matter. I'm just going to leave it as is. And then our last step is just dividing by that v plus 1. So now I have vt minus t over v plus 1 equaling s. If you wanted to take out that GCF of t there, then it would have looked like t times v minus 1 equals s times v plus 1. And so then you would have divided and you would have had t times v minus 1 over v plus 1 equals s. And so that would be acceptable as well. And there you have it. Okay, bye.